Okay, so we're going to be going over limits here. This is going to be a very, straightforward thing. I'm not going to explain, why limits are helpful, what you do with them. I'm just going to tell you how to analyze them. So if you're, cramming for a test or whatever, this is for you. So when you see a limit, it looks a little something like this, right? So you have limit, of course, right in here. Underneath it, you have as your variable approaches a number. So in this case, it's as x approaches 4. And then you have the function or the equation that the limit is analyzing. So here we have, again, limit as x approaches 4 of x squared plus 2x plus 3. So whenever you're analyzing a limit, all the time, or basically all the time, the first thing you do is you take the number that it gives you. So in this case, it's 4. In this case, it's 2. In this case, it's 3. And you plug it into the equation and just see what you get. So, and then once you do that, there's multiple different things that can happen, and depending on what happens, you decide what to do next. So here are the first 3 options that I'm going to show you, the first 3 things that can happen when you plug in the number. So in this case, we plug in 4 for x. You get 2 times 4 plus 3, you have 4 squared plus 2 times 4 plus 3 is equal to 16 plus 8 plus 3 equals 27. So you just get a number. The number is 27. In that case, you're done. That's it. You have found the answer to the limit. It's 27. If you get a number like, if you get 5, it's 5. If you get 0, it's 0. If you get, 0 divided by 7, so 0 divided by any number other than 0 is just equal to 0. 0 divided by 0 is a special case. We'll go over it later. But yeah, if you just get a number, that's it. You're done. That number is your answer. So next situation, we look right here. So in this case, we have the limit as x approaches 2 of x plus 5 divided by x minus 2. So that becomes 2 plus 5 divided by 2 minus 2. And that becomes 7 divided by 0, to which there is no solution. And that's because you can't divide by 0. Any number other than 0 divided by 0 is no sol, short for no solution. Again, if you have 0 divided by 0, that's special. But in this case, you have 7 divided by 0. No sol, it could be any number, 1,000,000 divided by 0, 1,000 divided by 0, it doesn't matter. It just means no solution. And if you look at this function on a chart, you'll see that what happens is as x approaches 2, you never actually get there. The chart just shoots off into infinity and you never reach it. You could say, maybe that the answer for this limit is, it's positive infinity as you approach from the positive side, or negative infinity as you approach from the negative side, but you don't need to worry about that. I don't think your professor will care if you just say no solution. That'll be fine. That'll be the right answer. And it's easier than trying to find, which way it goes, positive infinity or negative infinity. Now, the third thing that could happen, so in this case, we have the limit as x approaches 3 of the square root of x minus 8, which becomes the square root of 3 minus 8, which becomes the square root of negative 5. And again, this has no solution. And hopefully you know why. You can't square root a negative number. Square root of negative 5 has no answer, or at least no answer in, normal real world mathematics. You could say it's like, an imaginary number, but that's not important. And so if you don't understand why that's the case, just think about it for a bit. Let's say you have 25. The square root of 25 is 5, right? Because 5 times 5 equals 25. Now let's say you have negative 25. What's the square root of negative 25? Well, it can't be 5, because 5 times 5 is 25. And it can't be negative 5 either, because negative 5 times negative 5 is also 25, because a negative times a negative makes a positive. So there is no number that, when multiplied by itself, will make negative 25 or negative 5 or any other negative number. So therefore, no solution. If you graph this, if you graph the square root of x minus 8, you'll see that it doesn't even approach 3 at all. It just stops at 8 and that's it. So no solution, you're done. So these first 3 cases for limits are one step. You plug in the number and you get your answer and you're done. The rest of the cases are a bit more complicated. You're going to have to do a few more steps. Okay, so the next case is when you get 0 divided by 0. This is a big one. This is most likely, if you get a limit question, this is what's going to happen. You're going to get 0 over 0, and then you have to do stuff to it in order to figure out what's happening. Because when you get 0 over 0, what that means is you don't know what the limit is. There could not be a limit at all. There could be no solution, or the limit's a number you don't know. You're going to have to do more work to find it, and that more work is you're going to have to do some factoring. So let's take a look at this limit here. So we have the limit as x approaches 1 of 6x minus 6 divided by x minus 1. So as always, when you analyze a limit, first thing is you plug in the value. So we get 6 times 1 minus 6 divided by 1 minus 1. 6 times 1 is obviously just 6, so you get 6 minus 6 divided by 1 minus 1. 6 minus 6 is 0, 1 minus 1 is 0. You have 0 over 0. So now what we're going to do is we're going to factor. So this one's really simple. You could probably figure it out. And actually, I should mention this. I encourage you, of course, to try these things out on your own before I explain them, because obviously if you can do it on your own, then you don't need me to explain them. So 6x minus 6 at the top here, you can, of course, factor 6 out of this because both terms have 6. So you end up with 6 times x minus 1 divided by x minus 1. Now you can see I already crossed them out because, of course, x minus 1, they cancel out because they're on different sides of the fraction, and you just end up with 6. So in that case, that's your answer. The answer to this limit, or the evaluation of it, is 6. And in this case, because this is a really simple one, we completely cancel out the x's, right? There isn't even a, it doesn't exist anymore. So it's just going to be a straight line. If you look at the graph, it's just a straight line. However, if you go exactly to x equals 1, you'll see that it's undefined. That's because 0 divided by 0 is undefined. So at that specific moment, there is no value. Okay, so I wanted to show one more case of when you just need a factor. And so this is going to use a special rule that you do well to remember because it comes up often in these limit problems. So once again, we have 0 divided by 0. If you look here, limit as x approaches 5, x squared minus 25 divided by x minus 5, 5 squared minus 25, because again, we just plug in the number, 5 squared minus 25 divided by 5 minus 5, 25 minus 25 divided by 5 minus 5, 0 divided by 0. So once again, that just means we don't know the answer and we need to factor to try and find it. So how do you factor this? Well, at first glance, it doesn't seem obvious. However, there is a very helpful rule that you need to know. It's this right here. A squared minus b squared equals a plus b, a minus b. Very important rule. You should remember it, or at the very least, you should, as soon as you get a test or whatever, write it down at like the top of the test sheet so you have it written down, because professors really love to do this. They really love to give a limit where you have to apply this rule in order to find the answer. So just remember this rule. It's just a factoring rule. There's no tricks to it. Just memorize it. A squared minus b squared equals a plus b, a minus b. So how does that help us here? Well, we have x squared minus 25. And 25, hopefully you know this, is 5 squared. So you have x squared minus 5 squared. X squared minus 5 squared. A squared minus b squared. If we pretend that x is a and 5 is b, we have a squared minus b squared. So because we have a squared minus b squared, we can rearrange it like this. So over here, as you can see, I turn the 25 into 5 squared. X squared minus 5 squared, that's the same as a squared minus b squared. That becomes x plus 5, x minus 5, and of course it's still divided by x minus 5. So now we have x minus 5 here, x minus 5 here. We cancel out, and we're left with just x plus 5. So now, if we go back to our limit, it's as x approaches 5, and we plug in 5 for x, we get 5 plus 5 equals 10. So now we have an actual number, we have our answer, it's 10. And again, if you graph this, you'll see that it just looks like a normal line, but when you go to x equals 5, it's undefined, because at x equals 5, it's 0 over 0. And I already mentioned this earlier, but I want to mention it again. This right here, actually I didn't mention it earlier, so this isn't very important. Your professor probably won't care, but it's still worth noting. This right here, this x plus 5, does not equal this. Does not equal x squared minus 25 divided by x minus 5. And that might seem strange because if you graph both of these, you'll see that they look the same, right? It's the same line, they're right on top of each other. However, they do not equal each other. And the reason why is because, well, for two equations to equal each other, they have to give the exact same value at any x. So you plug in, 7 for the x values here, you plug in 7 for the x values here, they have to give you the same number for any x value, no matter what you do. However, we know that's not the case, right? Because if you plug in 5 as the x value here, you get 0 over 0. But if you plug in 5 as the x value here, you get 10. So these two can't be equal to each other. Again, it doesn't really matter, but if you, for some reason, on your test or whatever, on your assignment, write down that this equals this, your professor, if they're really, stingy, they might take off marks for that. So just keep that in mind. This does not equal this because at this specific x value, they give different answers. Okay, so we got another case here. So it's once again 0 over 0, but it's a bit different. For the sake of time, I didn't write it out. Just believe me, it's 0 over 0 if you want, you can check it on your own. But, so in this case, so we're going to have to factor again, but when you look at it right now, you can't really factor it, right? There's a square root or whatever. It doesn't look like you can factor it. So what are you going to do? Okay, so as I mentioned before, we have this rule. It's called difference of squares rule. I don't remember if I said that. So a squared minus b squared is equal to a minus b, a plus b. And if you look at the equation that we have here, 2 minus the square root of 1 plus x divided by x minus 3, you have right here a number minus the other number. So something minus something, a minus b. You're going to pretend that 2 is a and the square root of 1 plus x is b. You have a minus b, and you want to turn it into this. So you want to take a minus b and multiply it by a plus b. So basically you want to take 2 minus the square root of 1 plus x and multiply it by 2 plus the square root of 1 plus x. That's what I did here. Now that might seem a little bit strange, and so I'm going to explain a bit more. So first of all, you might also notice that there's x minus 3 here, which is also, you also could say is a minus b. But in this situation, you want to look at the top because there's a square root. And if there's a square root, that's the one you want to look at with this rule because it just makes things a lot easier. That's just how it works. That's how you should do it. So right here, we have our original equation, 2 minus the square root of 1 plus x divided by x minus 3. And we multiply it by 2 plus the square root of 1 plus x, which is the same as a plus b, divided by 2 plus the square root of 1 plus x. And that probably looks kind of weird. Why is that a thing? Well, okay, I have this example right here. So let's say you have the number 5, okay? And you take 5 and you multiply it by 3. So now you have 15. Totally different number, right? You took 5, you multiplied it by 3, which is a different number. You got 15. Different number, completely different, okay? But if instead, let's say you take 5 times 3 divided by 3, well, that's the same as 5 times 1, right? Because 3 divided by 3 is just 1. Something divided by itself is just 1, unless it's 0 divided by 0. That's special. This doesn't equal to 1. But if you have, in this case, you have something other than 0, so you have 3 divided by 3, that's the same as 1. So then you have 5 times 1, and 5 times 1 is just 5, right? If you take a number and multiply it by 1, it's just the same number. And you could even say, if you have 5 times, say, x divided by x. Well, x divided by x, right? You're taking x, dividing it by itself. That's just 1. So you have 5 times 1, and it equals to 5. So we go back to this equation we have right here. So if we multiply it by 2 plus the square root of 1 plus x, or, a plus b, if you just divide that by the same thing, if you just divide that by 2 plus the square root of 1 plus x, technically, you're just multiplying by 1. This is just equal to 1 because it's something divided by itself. And so you're just multiplying this by 1. And when you multiply something by 1, as we established here, you just get the same thing. Nothing changes, right? Multiply by 1, it stays the same. So by multiplying it by, a plus b, 2 plus the square root of 1 plus x, divided by itself, we're technically just multiplying by 1, which means we're technically not changing anything, right? This is technically the same thing. It's not exactly the same thing. Like I mentioned before, this equation that we find here is not equal to the original equation, but for the sake of finding a limit, this is actually the same thing. You're not actually changing anything. You're just doing a bit of rearrangement. So that's what we do. So we take this, our original equation, multiply it by, a plus b divided by a plus b. And then we have this right here. So, we have a minus b times a plus b. And then you also just multiply the denominators together. So you have x minus 3 here, 2 plus the square root of 1 plus x here. Just put them in brackets, multiply them together. And so now because we have a minus b times a plus b, we can go back to this rule, a squared minus b squared. And so, again, 2 is a, right? We established that 2 is a. The square root of 1 plus x is b. So you have 2 squared minus the square root of 1 plus x squared. And then it's divided by this. This sign, by the way, what this means is that it means the same thing. So basically here we have, this x minus 3 times 2 plus the square root of 1 plus x. This means the same thing. It means, I didn't want to rewrite it to save time. You just put this little symbol. It's pretty helpful. So we have 2 squared minus the square root of 1 plus x squared. 2 squared is just 4. And then if you have a square root and you square it, you basically just get rid of the square root and the square. Think about it. Let's say you have the square root of 25 squared. So the square root of 25 is 5, and then 5 squared is 25, right? A square root and a second power, they just cancel each other out. So we end up with 4 minus 1 minus x, right? Because this minus applies to everything in the square root. So it's minus 1 minus x. 4 minus 1 minus x divided by the same thing. And then over here, you see that simplifies to 3 minus x divided by the same thing. And then that in turn changes to negative x minus 3 divided by, it's the same thing, I just rewrote it again because now we're going to be working with it. If you don't know what I did here, why did 3 minus x turn into negative x minus 3? I have this little demonstration right here. So let's say you have 5 divided by 3, right? So if you have 5 divided by 3, and then you multiply 5 by negative 1, and you also multiply the entire fraction by negative 1, you actually end up with the same thing. This 5 divided by 3 is equal to negative 1 times 5 divided by 3, right? Because you're multiplying, first of all, you're multiplying by 1. And we established here, if you multiply by 1, nothing changes, right? You can multiply anything by 1 and it'll be the same thing. I can take this 2 right here, multiply it by 1 a million times, still 2. You can take this 3, multiply by 1 as many times as you want, it's still going to be 3. So by multiplying by 1 here, we're not changing anything. And we have 2 1s here, and they're both negative. And of course, if you multiply a negative by a negative, that's the same as, or that turns back into a positive. So if you take 5, multiply by negative 1, and then multiply by negative 1 again, well, you just get 5. It just goes back to 5, right? 5 times negative 1 times negative 1 just equal to 5. So 5 divided by 3 is equal to negative 5 divided by 3. These are the same thing because a negative times a negative turns back into a positive. And so that's what we did here. We have 3 minus x, or I guess you could say positive 3 minus x. And then we multiply this by negative 1, and we also multiply the entire fraction by negative 1. So we end up with a negative fraction, x minus 3. If this confuses you, it's the same thing as negative 3 plus x. So we switch the signs for these, end up with x minus 3. Hopefully that makes sense. Hopefully you didn't even need that explanation. So now we have x minus 3 at the top, and then of course right here we also have x minus 3. So x minus 3 cancels out. You end up with this, negative 1 divided by 2 plus the square root of 1 plus x. And so now that we have this, we're going to go back to our limit. Limit is, of course, as x approaches 3, you're going to plug 3 in for this x. And again, I didn't write it out for time's sake, but you end up with negative 1 divided by 4. And that's the answer for this limit. The limit as x approaches 3 of this equation is negative 1 over 4. And if you look at the chart, that's exactly what you have. Okay, so now I have something a little bit different. Here we have a limit, but instead of x approaching a number, it's x approaching infinity. So don't get scared. In my opinion, actually, these questions are easier because what you're supposed to do to solve them is usually more straightforward. So anyways, let's just look at it. So we have the limit as x approaches infinity of x plus 2 divided by 2x minus 7. So again, we plug in the x value, which in this case is infinity. So we have infinity plus 2 divided by 2 times infinity minus 7, which equals to infinity over infinity. And so first of all, the reason why this whole thing just becomes infinity over infinity is because basically infinity is a bit of a special number, right? Or it's not really a number at all. It's like an idea. No one really knows what it is, Talk to mathematicians, they'll say it's infinity is an idea or it's a concept or it's made up. But really what we're saying is, okay, infinity plus 2. What's that? Well, it's, if you add 2 to infinity, it's still infinity, right? Let's see, have infinity plus a million. I mean, it's still infinity. If you have infinity minus, say, 999 trillion, well, it's still infinity, right? Because even if you have infinity, even if you subtract a really big number from it, infinity is way bigger than that really big number. It's infinitely big. And so even if you, take infinity and you subtract or add to it, or you multiply it, like in this case, or multiplying it by 2 or whatever, it's still just infinity, right? None of that really matters. You still just have infinity. So if that makes sense, great. If not, then just remember this. If you have infinity in the numerator and the denominator, it just simples out to infinity over infinity. It's that simple. So in this case, what we're going to do, it's actually really easy. So first of all, you're going to find the highest power of x that's in the equation. So look at our x's. What's the highest power? Well, it's just 1, right? I mean, you don't write it down, but this is x to the power 1. This is x to the power 1. The highest power of x that we have in this equation is 1. So now what you're going to do is you're going to divide every single term in your equation by x to the highest power that you found. So we're going to divide every single term by x to the power 1, which is just dividing by x. So that's what we have right here. We have x divided by x, right? Because that's what I just said. And we have 2 divided by x. Then over here we have 2x, right? We have 2x. We divide it by x. And we have minus 7 divided by x. So that's what we have. Now, of course, that simplifies a bit, right? X divided by x. Well, like we talked about before, if you take something and divide it by itself, it's just equal to 1. So x divided by x becomes 1. 2 divided by x, we don't touch that. If you can't simplify it, then just leave it. 2 times x divided by x. Well, again, x divided by x is just 1. 2 times 1, just 2. And right here we have minus 7 divided by x. We're not going to touch it. So then over here, you see what happens is 2 divided by x and 7 divided by x, they each become 0. So you have 1 plus 0 divided by 2 minus 0. And that might be a bit complicated, so I have this example right here to explain. So let's say you have 5, and you're dividing it. First, you divide it by 10, right? You have 5 divided by 10, you get 0.5. Then you have 5 divided by 100, you get 0.05. You have 5 divided by 1,000, you get 0.005. So you're probably noticing a trend. As the number at the bottom becomes bigger, the answer becomes smaller, right? And so right here, if we have 5 divided by, 99999, like 100 nines, the answer we get is really small. It's 0.000000, so on and so forth. The number is getting, as this number gets bigger, as the denominator gets bigger, the answer gets smaller. So, by that logic, if the denominator is infinity, which is infinitely large, then the answer becomes infinitely small, which means it becomes 0. So basically, you divide every term by x to the highest power, and then if you are left with any of these fractions, right, 2 divided by x, 7 divided by x, anything else divided by x, those just turn into 0. That's it. You just turn into 0, and then once you do that, now you can analyze. So now we have just 1 plus 0 divided by 2 minus 0, and that's of course just 1 divided by 2. And that's the answer. The limit as x approaches infinity here is 1 divided by 2. So like I said, when you have infinity, it's actually usually a lot easier because all you do usually, or not usually, sometimes what you do is you just divide the terms by x, and then you just turn these into zeros, and then you just have a very simple number that you just find the answer. Okay, so unfortunately limits are not always so simple. If you have a limit to the infinity, you can't always just immediately go to dividing by the greatest power of x. Sometimes you have to do a little bit more work, and this is one of those cases. So we have a limit as x approaches infinity of the square root of x squared minus 8x divided by 2x plus 1, which equals infinity over infinity. I'm not going to write it out, just trust me, or check on your own if you want to be sure. And so the reason why we can't just immediately divide each x by the greatest power is because we have this square root. Basically, if there's a square root and you have x within it, and you have more than one term in the square root, that's the big deal, then you have to do a bit more work. That's how it is. If that didn't make sense, don't worry about it. Basically, all I need to know, you have a limit as x approaches infinity. You have a square root completely covering either the numerator or the denominator. So the square root is over the entire thing here, right? It's not just the square root of x squared or just the square root minus 8x. It's the whole thing. If you have this, then you have to do a bit more work. So what are we going to do? Well, we want to put all of this under one square root because that'll make things a lot easier. And how do we do that? Well, the top is already square rooted, of course, so we just need to make the bottom square rooted. So what we're going to do is we're going to take 2x plus 1, we're going to square it, so we're going to raise it to the second power, and then we're going to square root that. And so when you raise something to the second power and then square root it, they cancel each other out, right? 5 squared is 25, the square root of 25 is 5, right? So this square root and this power just cancel each other out, right? They don't actually change anything, right? It doesn't change the number, it doesn't change the value. Technically, in this case, when analyzing limits, in reality it does, but don't worry about it. Just this is what you do. And for limits, this is fine. And then we can combine the two square roots, the square root that covers the whole numerator and the square root that covers the whole denominator, into one square root. And that's just because of this simple rule. The square root of a divided by the square root of b is equal to the square root of a divided by b combined. That's just a math rule. If you didn't know that, now you do. Write it down, memorize it. It's pretty important. And so we now have this whole thing under a square root. And so this is helpful because so now we basically have the limit as x approaches infinity of this whole square root. And there's another rule that's pretty helpful right here. So if you have a limit as x approaches whatever, as x approaches n in this case, of the square root of x, in this case just the square root of x, but it can be the square root of, it can be this, it can be the square root of x squared, it can be the square root of x squared minus 8x, doesn't matter. If you have the limit as x approaches n, and then the entire equation that you're looking at for the limit is under a square root, then you can just do this. You can take the square root outside, so now you just have the limit as x approaches n of x, and then once you find the limit of this, you just square root your answer. So that's what we have right here. So we have this square root right here. And so what we're going to do is, so first of all, I'm just going to remove the square root. It's not actually gone. I'm just going to not draw it to make it easier. You have to remember to reapply the square root. So some of you might have already noticed a mistake here. So we have x squared minus 8x, 2x plus 1 squared. I expanded it here. So 4x squared plus 4x plus 1. I really hope you know how to do that. A plus b squared expands to a squared plus 2ab plus b squared. So we have this. And so now we're going to do what we did last time. We're going to find what the highest power of x is, and we're going to divide every single term by x. So in this case, the highest power is squared, or to the second, right? Because we have x squared here, we have x squared here. We don't have anything bigger than that. So we're going to divide every single term by x squared. So x squared divided by x squared minus 8 times x divided by x squared. And then all that's divided by 4, x squared divided by x squared plus 4x divided by x squared plus 1 divided by x squared. And like before, like I talked about, so first of all, x squared divided by x squared, that's just equal to 1. 4 times x squared divided by x squared, that's just equal to 4. And then everything else here, right, we have 8 times x divided by x squared, x divided by x squared. So that turns into 0. And let me explain why, because that's a little bit different than what we had before. So, okay, so we're basically so we have x divided by x squared, right? So if you put infinity in, so if you do infinity divided by infinity squared, basically, if you just have infinity divided by infinity, that just means we don't know. But if you have infinity divided by infinity squared, then that equals to 0. Previously, I said that, right, if you have 2 times infinity, it's just infinity. If you infinity minus 7 or whatever, it's still just infinity. And so no matter what you do to infinity, it just stays infinity. But there is an exception, and that is if you raise infinity to a power. If you have infinity squared, then it is bigger than just infinity. If you infinity cubed, it's bigger than infinity squared. So the power does matter. So in this case, you have x divided by x squared. This will just turn into 0. Now, if that doesn't make sense, right, if that's a bit complicated for you, then don't worry. You can just look at this a little bit of a different way. You have x divided by x squared. If you cancel out one, so there's x in each of these terms, right? So you can cancel out one x in each of these. So it ends up being 1 divided by x. And in this case, now I think you understand, right? 1 divided by x, as x approaches infinity, this just turns into 0. So hopefully you get that. If you don't, then, just remember this, right? If you have something here, and then if you have x here, and then you have a greater power of x at the bottom, then that just turns into 0. So because of that, this 8, x divided by x squared, that turns into 0. 4 times x divided by x squared, that turns into 0. And 1 divided by x squared, that turns into 0. So we have 1 divided by 4. However, like I said, you're actually not done, because if you remember, this was all square rooted, right? We found the limit, we found this, the limit as x approaches n of x, but we removed the square root, we put outside. So we actually have to take this and square root it. And the square root of 1 divided by 4 is 1 divided by 2. Okay, so we're basically done, but I do still want to show some other things that could happen. These are the last 2 possible outcomes when you plug in your value. And these probably won't turn up on a test, but he might throw it in as a trick question or whatever. So just in case, keep these in mind. They're pretty straightforward. And I also kind of covered it in the last step, but if you didn't understand my explanation, hopefully you watch this and it starts to make sense. So right here we have the limit as x approaches infinity, x squared plus 5x divided by x plus 3. So we plug in infinity. We have infinity squared plus 5 times infinity, and sorry if my infinities look weird, they're just kind of hard to draw, divided by infinity plus 3. So like I said before, infinity plus 3 or whatever, the plus 3 goes away, right? You can add or subtract any number to infinity, it's still infinity. If we had, 4 times infinity here, the times 4 go away as well, right? You can take infinity, multiply it by 4, it's still infinity. You can divide it by 1,000,000,000,000, it's still infinity, right? So we just have infinity here. But you'll notice here we have infinity squared. And that's because right here we have infinity squared. Like I mentioned in the last clip, if you have infinity raised to a higher power, then that is the greater infinity. Infinity, if you multiply infinity by, a number like 5, it doesn't change, right? It's still this infinity. But if you raise infinity to a higher power, then that is bigger, right? Infinity squared is bigger than just infinity. Or, in this case, 5 times infinity. Infinity cubed is bigger than infinity squared. And that's important to keep track of. So we end up with infinity squared divided by infinity, and that just equals to infinity, because infinity squared is bigger than infinity. So as x approaches infinity, you end up with infinity. And if you were to graph this, you would see that this graph just, endlessly goes upwards to infinity. And here we have the opposite situation. So we have the limit as x approaches infinity, x minus 7 divided by x squared plus 8. So we plug in infinity, infinity minus 7 divided by infinity squared plus 8, minus 7 plus 8 go away. And you have infinity divided by infinity squared. So infinity squared is bigger than infinity, And so because of that, like we talked about before, right? As the denominator grows bigger, the final answer gets smaller and it approaches 0, right? If you have 5 divided by 10, it's 0.5. If you have 5 divided by 100, it's 0.05. If you have 5 divided by, a million, it's 0.0000, whatever. And if you have 5 divided by infinity, it's 0. And it's the same idea here. If you infinity divided by infinity squared, which is bigger than infinity, then you end up with 0. So you could, like I said, you probably won't get this because assuming you understand this concept, this is a very easy question, right? You just, you look at what you have and immediately the answer is either 0 or infinity, but it is worth keeping in mind. And it is helpful in the last step that I showed you guys. And that's it. That's all the cases of limits that you can get. If you understand this, then you should be totally fine for any limit questions. There is one more thing I'm going to show you. That's a sort of last ditch effort in case this doesn't work. So let's look at that. Okay, so there's one more thing I should mention. So let's say you have the limit as x approaches, and I wrote 3, but it doesn't matter what it is, of something, right? Just whatever, some equation here, and it equals to 0 over 0. And let's just say, you tried all the solutions I showed you before, but it just didn't work out. You couldn't factor it, you couldn't multiply by conjugate, which is that thing with like the square root multiplied by itself. All that stuff, like nothing worked, right? You can't find the answer. So in that case, what you're gonna do, and I didn't write it out because it's a lot of work, and this is like a last resort. You shouldn't do this unless you have to. What you're gonna do is, so you're gonna take your equation, whatever it might be, and you're going to start bringing the x value closer to whatever the limit is. So in this case, you have a limit as x approaches 3. So what you're going to do is you're going to take your equation, and for the x value, you're going to plug in, let's say, 2.5. So you plug in 2.5 into whatever your equation is, and you get a number. You get an answer. Let's just, whatever. It doesn't matter. You get some answer. Okay, so now what you're going to do is you're going to plug in another number now that's closer to 3. So we start with 2.5. Now we're going to do 2.9. So you plug in 2.9 into your equation, and you get an answer. Then you're going to do it again, but you're going to go even closer to 3. So we had 2.9. Now you're going to do 2.99. You plug that in, see what you get. Do it again, 2.999, see what you get, and so on and so forth. And you can do it, technically as many times as you want. And so what you're doing when this happens is basically you are approaching x equals 3. And as you approach it, you find what the limit is, right? So if let's say you plug in x 2.5 and you get the number 9. Then you plug in x 2.9 and you get 9.9. And then you plug in x 2.99 and you get 9.99. Plug in x 2.999, you get 9.999. Well, it looks as if the limit as x approaches 3 is 10, right? Because you're getting closer and closer to the number 10 as your x value gets closer and closer to 3. And so 10 would be the limit. And then if you're going to do that, then you should also do it from the other side. So just now we started from 2.5, which is less than 3. Now we want to go from the other side. We want to go from whatever is more than 3. So we'll start with, let's say, 3.5. Plug it in, you get, whatever. Then you go down to, let's say, 3.1. Plug it in, get a number. You go down to 3.01. Plug it in, get a number, 3.001, so on and so forth. And you'll see that number also approaches 10, but this time from greater numbers. So let's say you plug in 3.5 and you get 11, then you plug in 3.1 and you get 10.1, you plug in 3.01, you get 10.01, and so on and so forth. So basically, you want to do that because you want to sort of pinch the number. You want to pinch what the limit is. And so you will find from that, you can use that to find the limit. If, the previous things didn't work. Like I said, that's not a good thing to do because for one, it's a lot of writing, right? You have to write out the equation with x 2.5, calculate that, write down your number, then x 2.9, calculate that, write down your number. Keep doing it until you get close enough, and then do it again from the other side, and that's just to be sure because you don't know what might be happening. Maybe from the other side you get something totally different. And even then, so that takes a while. And even then, it's bad because you're only getting an approximate number. You don't know for sure that you're finding the correct limit. You're approaching a number. In this case, we're approaching, or in the case I made up, we're approaching 10, but you don't know for sure it's 10. Like, let's say, for example, the limit is actually 10.001 or let's say it's 10.00000, 1,000 zeros and then 1. If you're just doing the approach method that I just explained, you won't know that the limit is 1,000 zeros 1. You're just going to think it's 10 because that's what it looks like. So basically this method that I just explained, it's pretty imprecise and it's not good. You don't want to do it unless either the question specifically asks you to do it or the other things that I showed you that didn't work. You tried them and you couldn't do it. Then you can try that approach method, but it's not good. Don't recommend it. It's good to keep in mind that, you can do it if all else fails, but it's definitely a last resort. Try to avoid doing it. And with that, we're done with limits. That's it.